Welcome, my dear student, in this third lecture of chapter number 4, Integration and its application. In the last lecture, we have learned about the substitution in integration and some formulae and examples on it. Today, we are going to learn the same thing about substitution, but specially trigonometric substitution. Sometimes what happen that integrand, trigonometric integrand cannot be integrate easily. So if we take proper substitution, then it can be converted into such integrand that it can be easily integrated. So let's go to the substitution of about in trigonometric. Let's trigonometric substitution. Let's see some standard trigonometric substitution. Integrands and substitutions. Suppose the integrand is of this form, square root a square minus x square. Then we will take the substitution x equal to a sine theta, or we will take x equal to a cos theta. If the integrand is of the form x square minus a square, then we will take the substitution x equal to a sec theta, or x equal to a cosec theta. If the integrand is of the form x square plus a square, then take x equal to a tan theta, or x equal to a cot theta. Okay. If integrand is of the form a plus x, then take x equal to a sine, this is minus a minus x, then take integrand x equal to a sine square theta, or x equal to a cos square theta. If integrand is of the form a plus x, then take x equal to a tan square theta, or x equal to a cos 2 theta. Okay, so you can take the substitution like this if the integrand is of one of this form. Okay, let's see one last. If the integrand is of the form 2ax minus x square, then take x equal to 2a sine square theta. These are some standard substitutions, so note it down in your notebook. Now we will see some examples on it. Okay, let's see some example. Example number 1. Integrate square root of x square minus 1 upon x dx, where x is greater than 1. Now we want to find the integration of this. So we have to take proper substitution, trigonometric substitution, to integrate this. So what will be that substitution? So we will take, let x equal to sec theta, x equal to sec theta. Then differentiate this x with respect to theta. We will get dx by d theta equal to sec theta into tan theta. Therefore dx equal to sec theta into tan theta into d theta. Okay. Now substitute all these things in the data. So we have integration square root x square, x is equal to sec theta, so x square is sec square theta minus 1 upon x, x is sec theta into dx, dx is sec theta into tan theta into d theta. Okay, this sec theta will be cancelled out. Now what is sec square theta minus 1? Sec square theta minus 1 is nothing but tan square theta into tan theta d theta. Okay, I think this all of you can understand these things. Now what is the square root of tan square theta? Square root of tan square theta is tan theta. So we have I equal to integration tan theta into tan theta d theta. This is nothing but tan square theta into d theta. Now we don't have the integration of tan square theta. So tan square, we all know that tan square theta is nothing but sec square theta minus 1 d theta. Now integration of sec square theta is tan theta minus integration of 1 is theta plus arbitrary constant c. Now we get this answer. But see, our original data is in x and our answer is in theta. Okay, so we have to convert this theta in the form of x. So how will you convert? We can see we have taken the substitution x equal to sec theta. So sec, we can write x instead of sec theta. This is tan theta. So let's convert this tan theta into sec theta. So this is nothing but under root tan square theta minus theta plus c. Now tan square theta is sec square theta minus 1 minus theta plus c. Now we all know that what is sec theta? Sec theta is x, so the answer is x square minus 1. But what about theta? Let's see. We have to take the substitution sec theta equal to x. So by inverse trigonometric function, theta equal to sec inverse x. So write down sec inverse x in place of theta. So we have sec inverse x and plus c. So this is our answer. So in this way you can do substitution and find the integration of some functions. Okay, now let's see one more example. example number 2. Integration x square upon square root of a raised to 6 minus x raised to 6 dx, where a greater than 0. Now we want to find this integration, so we have to take proper substitution. So let's take x cube equal to a cube sine theta. Okay, now differentiate this with respect to theta. So this is 3x square into dx equal to a cube, derivative of sine theta is cos theta into d theta. Therefore x square dx equal to a cube by 3 cos theta d theta. Okay, now let's substitute all these things in I. So we have x square dx. See, let's write down x square into dx upon square root a raised to 6 minus x cube square. Okay, so what happens here? We have integration x square dx is a cube by 3 cos theta d theta, and square root a raised to 6 minus x cube is a cube sine theta, and this is x cube square. So x cube whole square is a raised to 6 sine square theta. Okay, now therefore I equal to integration a cube cos theta upon 3. You can take a raised to 6 outside, and this is square root, so a cube will be taken common, and in the square root 1 minus sine square theta d theta. A cube will be cancel out. 1 upon 3 is constant. Integration cos theta upon 1 minus sine square theta is nothing but cos square theta d theta. Now 1 by 3 cos theta upon cos theta d theta. So this is equal to 1 by 3 integration 1 d theta, and so 1 by 3 into theta plus c I equal to. Okay, 1 by 3 theta plus c, but again we have to convert this theta in the form of x. Now how will you convert? See, our substitution is like this: a cube sine theta equal to x cube. Therefore sine theta equal to x cube upon a cube. Therefore theta equal to sine inverse x cube by a cube. So we can write this I as 1 by 3 theta is sine inverse x cube upon a cube plus C. So this is the answer. I think now all of you can understand how to take substitution in trigonometric as a trigonometric functions. Now let's do one more example for this. Example number 3. I equal to integration 1 over a square plus x square whole raised to 3 by 2 dx. Whole raised to 3 by 2 dx. Now this is of the form a square plus x square. So let x equal to a tan theta. Now differentiate this x with respect to theta. So we have dx equal to a, derivative of tan theta is sec square theta into d theta. Okay. Now let's substitute all these things in I. So we have integration 1 over a square. X square means a square tan square theta whole raised to 3 by 2, and dx is a sec square theta d theta. Okay. Integration this a sec square theta upon, we can take a square common. If you take a square common, then there is the power a square raised to 3 by 2. So you will get a cube in the bracket 1 plus tan square theta whole raised to 3 by 2 d theta. Okay. Now this is equal to integration a sec square theta upon a cube. 1 plus tan square theta is sec square theta. So sec square theta whole raised to 3 by 2 d theta. See, here it is a and this is a cube. So 1a will be cancelled out. So the remaining term is 1 upon a square integration sec square theta upon sec square theta raised to 3 by 2. This 2 will be cancelled out. So the answer is sec cube theta d theta. Okay. Now you can see that this is sec square theta, this is sec cube theta. So 1 upon a square integration 1 sec square will be cancelled out. So 1 upon sec theta d theta. This is a square. 1 upon sec theta is nothing but cos theta d theta. And what is the integration of cos theta? Integration of cos theta is sin theta plus c. So this is our I. But still we have to convert this sin theta into the form of x. Now let's convert it. We all know that what is our substitution? Our substitution is x equal to a tan theta. Therefore tan theta equal to x upon a. Okay. Now you can convert this tan theta into sin theta using the identities, or you can convert it like this. This is right angle triangle. Suppose this angle is theta. Tan theta is x upon a. So x is this and a is this. tan theta equal to x upon a. Now in the right angle triangle, by Pythagoras theorem, this is x, this is a. The hypotenuse is square root x square plus a square. So from this we can write what is sine theta. Sine theta equal to x upon square root x square plus a square. Okay, now substitute this x equal to x upon under root x square plus a square here. So we will get I equal to 1 upon a square x upon square root x square plus a square plus c. So this is our answer. I think by these three examples you all can understand how to integrate and how to use the trigonometric substitution. Okay. Now let's see one more trigonometric substitution which is very important and special. If the integrand is of the form 1 upon a plus b sin x or 1 upon a plus b cos x or 1 upon a plus b sin x plus c cos x. If the integrand is one of this form, then take the substitution tan x by 2 equal to t. This is very important substitution. Tan x by 2 equal to t. If the integrand is one of these three form, then take the substitution x by 2 equal to t. Now differentiate this with respect to x. So derivative of tan x by 2 is sec square x by 2, and derivative of x by 2 is 1 by 2 into dx, and derivative of 1 is t is 1, so dt. Therefore, what is dx? Dx is equal to, this 2 will be this side, and sec square x by 2 dx. Now you can convert this into the form of t. Sec square is 1 plus tan square x by 2, sorry, this is dt. Now what is tan x by 2? Tan x by 2 equal to t. So we can write this 2 upon 1 plus t square dt. This is dx. So remember this, if you take tan x by 2 equal to t, then dx is 2 upon 1 plus t square dt. Now the question is, what about sin x and cos x? Here our substitution is tan x by 2 equal to t. Then we have to find the value of sin x and cos x in terms of t. So we have the formulas that sin x in term of tan x by 2, sin x equal to 2 tan x by 2 upon 1 plus tan square x by 2. These are the trigonometric formulas. So, but tan x by 2 is t. So, sin x is 2t upon 1 plus t square. And cos x equal to 1 minus tan square x by 2 upon 1 plus tan square x by 2. This is equal to 1 minus t square upon 1 plus t square. So if you take this substitution, tan x by 2 equal to t, then take dx equal to this and sin x equal to this, 2t upon 1 plus t square, and cos x equal to 1 minus t square upon 1 plus t square. We will use these three things in this type of examples. Okay, so please note down these all things in your notebook. Now let's do some examples on it. Example number 1. Find the integration I equal to dx upon 2 plus 3 cos x. See, this is the form like 1 upon a plus b cos x. Here a is 2, b is 3. Okay, so we'll take the substitution tan x by 2 equal to t. So let tan x by 2 equal to t, and just we have seen that what is dx? Dx is 2 upon 1 plus t square dt. Okay, we will substitute this in place of dx. And what is cos x? Cos x equal to 1 minus t square upon 1 plus t square. So we will substitute this in place of cos x. Okay, so let's substitute these two things in this. So we have I equal to integration dx is 2 of, first of all write down this thing, this is 2 plus 3, and what is cos x? Cos x is 1 minus t square upon 1 plus t square into what is dx? Dx is 2 upon 1 plus t square dt. Now let's simplify this. Take the LCM, 1 plus t square will be multiplied with this 2, and numerator will be go to the denominator will be go to the numerator here. So this is 1 plus t square. If you multiply this by 2, you will get 2 into 1 is 2 plus 2 into t square is 2t square plus multiply by 3, so 3 minus 3t square into 2 upon 1 plus t square, this is into dt. Now you can see that 1 plus t square will be cancelled out. Let's simplify this denominator. This is 2t square, this is minus 3t square. This is 2 plus 3, 2 plus 3 is 5. This is 2t square minus 3t square is minus t square. Now see, this is the known form, square root 5 whole square minus t square. This is the form like integration 1 upon a square minus x square, which we have learned in the first lecture. So what is the integration of this? 2. 1 upon a square minus x square is log x plus a upon log x minus a. So this is mode x is t plus square root 5 upon t minus square root 5 plus c. Okay, but our question is in the x and this is in t, so we have to again convert this t into the form of x. Now we all know that what is t? T is tan x by 2. plus square root 5 upon 10 x by 2 minus square root 5 plus c. So this is our I. Now in this way you can integrate such functions. Okay, this is very important substitution. Let's see one more example for this. I equal to integration dx upon 5 plus 4 cos x plus 3 sin x. Okay, now this is of the form a plus b cos x plus c sin x. So again we will take the substitution 10x by 2 equal to t. Okay, and we all know what we are going to write here. For cos x 1 minus t square upon 1 plus t square, for sin x 2t upon 1 plus t square, and for dx 2 upon 1 plus t square dt. So we are not going to write here. Let's substitute all the things. 1 over, this is 5, 4 cos x is 1 minus t square upon 1 plus t square plus 3 2t upon 1 plus t square into dx is 2 upon 1 plus t square dt. Okay, now take the LCM here. So we have this 1 plus t square was in the numerator, so 1 plus t square, 1 plus t square will multiply by with 5, so 5 plus 5t square plus multiply this 4, so 4 into 1 is 4 minus 4t square plus 3 into 2 6t into 2 upon 1 plus t square dt. This is 1 plus t square, 1 plus t square will be cancelled out. This is 2 upon c. This is 5t square minus 4t square. 5t square minus 4t square is t square. Then this is 6t, so plus 6t. 5 plus 4 is 9, so plus 9 dt. Okay, now so this is equal to 2 integration dt upon, this is nothing but t plus 3 whole square. Okay, so this is equal to 2 integration t plus 3 whole raised to minus 2 dt. Now integrate this by the formula x raised to n. X raised to integration of x raised to n is x raised to n plus 1 upon n plus 1. So 2. This is t plus 3 raised to minus 2 plus 1 is minus 1 upon minus 1 plus c. Okay, so the answer is, this is minus, so minus 2, this t plus 3 raised to minus 1, so this is 2 upon t plus 3 plus c. Now again substitute 10x by 2 in place of t, so the answer is minus 2 upon 10x by 2 plus 3 plus c. So this is our answer. Okay, so these are some important substitutions. I think all of you can understand this substitution. Please note down this in your notebook. Now we will learn some more trigonometric substitution. if the integrand I is of the form sin raised to mx into cos raised to nx dx, where m and n both are in set of natural numbers. ઓકે, આ પ્રકારનો ઇન્ટિગ્રાન્ડ હોય તો સબસ્ટિટ્યુશન કેવી રીતે લેવું? So let's see, this is the value of m, value of n, and substitution. Suppose the m and n, this is n, both odd, m and n both are odd, then take sin x equal to t or cos x equal to t. You can take both sin x equal to t or cos x equal to t. If m is odd, means the power of sin is odd and power of cos n is even. Okay, then take cos x equal to t. If the power of sin, that is m, is even and power of cos n is odd, then take sin x equal to t. And if both the powers are even, then we have to use this formula, sin square x equal to 1 minus cos 2x by 2 and cos square x equal to 1 plus cos 2x by 2. We have to use these two formulae. In this situation, we don't need to take substitution. So this is the method how to take substitution in such forms, sin raised to mx plus cos raised to nx. See here again, if both are odd, then you can take the substitution for sin x or cos x both. If power of sin is odd and power of cos is even, then take cos x equal to t. If power of sin is even and power of cos is odd, then take sin x equal to t. And if both the powers are even, then use this formula. Okay, we will see how we are going to use this. Let's see one example on it. Integration sin raised to 4x into cos cube x dx. Okay, see here, this is m is 4, n is 3, this is even, this is odd, so we have to take the substitution for even power. So we will take sin x equal to t. So let sin x equal to t. Differentiate this with respect to x. So cos x into dx equal to dt. Now see here, this is sin raised to 4x into cos cube x. We will write cos square x into cos x dx. Again see this sin raised to 4x, same thing. In place of cos square x, we will write 1 minus sin square x into cos x dx. Now substitute sin x equal to t. So this is t raised to 4 into 1 minus this is t square. And what about cos x into dx? See, this is cos x into dx is dt. So this is dt. Now it is very simple. Multiply this to t raised to 4 minus t raised to 6 dt. Okay. Now integrate this. So integration is t raised to 5 upon 5 minus t raised to 7 upon 7 plus c. Okay, now we have to substitute sin x in place of t. So the answer is 1 upon 5. T raised to 5 means sin raised to 5x minus 1 upon 7. T raised to 7 means sin raised to 7x plus c. So this is the integration answer. Okay, I think you all can understand this thing, how we integrate this. Okay, now let's understand one more example. If both are even, I equal to integration sin square x into cos raised to 4x dx. See here, both are even. Okay, so as we have said that we have to use the sin formula for sin square x and cos square x, but divide by 4 and multiply this by 4. So 4 sin square x into cos square x, this is cos raised to 4, so under 2 power cos square x dx. Okay, now this is a formula for sin 2 theta. So 1 upon 4 integration, this is sin square 2x into cos square x dx. Now we will use those formulae. Sin square 2x is 1 minus cos 4x divided by 2 into cos square x is 1 plus cos 2x divided by 2 dx. Okay, now this is 2 into 2 4, 4 into 4 16, so 1 upon 16 integration, expand this 2, so 1 into 1 is 1, 1 into plus cos 2x is plus cos 2x, minus cos 4x into 1 is minus cos 4x into minus cos 4x into plus cos 2x, so minus cos 4x into cos 2x dx. Now we can integrate all the terms, 1, this, but we have no formula for this. So we have to convert this multiplication in addition or substitution. So multiply and divide by 2, so we have 32 integration 2 plus 2 cos 2x minus 2 cos 4x minus 2 cos 4x into cos 2x dx. Okay, 1 upon 32, 2 plus 2 cos 2x minus 2 cos 4x, 2 cos means cos plus cos, but here it is minus, so minus cos alpha plus beta means 6x minus cos alpha minus beta is 2x dx. 1 upon 32 integration, this is 2 cos 2x minus cos 2x is nothing but plus cos 2x minus 2 cos 4x minus cos 6x dx. Okay, so this is equal to 1 upon 32. The answer is integration of 2 is 2x plus integration of cos x is, what is the integration of cos x? It is sin 2x and the coefficient of x is 2, so write down in the denominator minus 2. Integration of cos 4x is sin 4x, coefficient of x is 4, so this is 4, minus integration of cos 6x is sin 6x, coefficient of x is 6 plus c. Okay, now see this is, so this is equal to 1 upon 32 2x plus sine 2x by 2 minus, you can cancel out this 2, so sine 4x by 2 minus sine 6x by 6 plus c. This is the answer. Or you can take LCM over here and write down in that form. I think all of you can understand. Now I am giving you some examples to try yourself. Integrate the following function with respect to x. Integration x square plus 1, square root of x square plus 1 over x dx. Second, integration of dx over 9 plus x square whole raised to 3 by 2. Integration of 1 upon 1 plus 2 cos x dx. Integration of 1 over 3 cos x minus 4 sin x plus 5 dx. This both are, in both you have to take substitution, trigonometric substitution. In these two you have to take the substitution tan x by 2 equal to t, and integration of cos cube x into sin square x dx. And sixth, integration sin raised to 4x. In this you have to take the substitution sin x equal to t, because the power of this sign is 2 and which is even, and this is odd, and here both the power are even, so you have to use the formula sin square x equal to 1 minus cos x by 2, and sin cos square x will be 1 plus cos 2x by 2. Okay, thank you very much. I think all of you can understand these things. Please do the exercise that I have given to you. Okay, and we will meet again for part 4 of this chapter. Thank you very much.